Good afternoon, everybody. My name is Nick Spaulding. I'm the SI leader for Math 1121. We'll be going over sections 4.4, 4.7, and 4.8 for this SI session. And I think we're starting with the exercise at the book, which is 4.4. Homework 4.4. I don't know. But you sure it's 4.4?
That's what he kept saying in class.
Yeah, the related rates.
Okay. Would you like to do one of those first? Related rates?
I think the one he really specified was like that cone one.
The cone. Okay. I
Number
think I know what you're talking
17.
about. Number 17 of the book.
I think he might like throw some different numbers
Okay.
in there.
You want to go over that one?
Up to you.
Huh? Okay.
Yeah,
I'll start with that
up
one.
to you.
Okay. Number 17, section 4.4.
Yeah, 'cause I didn't know.
Number 17. Okay. The problem reads: a tank in the shape of an inverted cone has a height of 3.6 meters. I'm drawing my cone, and it has a height of 3.6 meters. And a radius at the top of 1.15 meters. So this radius is 1.15 meters. Water is flowing into the tank at a rate of 0.5 meters cubed a minute. So the rate, or you could say dV over dt, which is volume.
That's the rate.
Yeah, rate of volume. The volume is over with time.
Okay.
Volume is filling up with time, and that's 0.5 meters cubed a minute.
Yeah.
Volume over time. How fast is the level rising when it is 1.8 meters deep? So when it is right here at 1.8 meters deep, what is dV dt then? At 1.8 meters. Okay. I'm gonna start off with the equation, volume equation of a cone, which is, I'm right up here, V equals 1 over 3 pi r cubed, right? Cubed.
R
Is that right? R squared?
squared.
It's R squared?
Times
H.
H.
Okay. 1/3 pi r squared H. So we're going to take this equation and make it a function of time versus time. So dV dt equals 1/3. These are all constants. 1/3 pi. All those are constants. R squared. Think about this. This is your big cone, and this is your little cone. This is 1.15, and this you don't know. R prime. Some notes on here somewhere. look for some notes real quick. I'm sorry about that. Got it. Okay. You want to relate with this small cone? What you trying to find? That's where you're trying to find the volume, the rate of volume. You want to relate it to the big cone where you have the geometry. So you can, the proportion, it's going to be proportional. The radius is going to be proportional when it's down here. So basically you do it like this. 1.15 over 3.6 is equal to R prime over 1.8, and then cross multiply. 3.6 R prime equals 1.15 times 1.8. R prime equals, you do that math for me? R prime?
Yeah, 0.575.
75. Okay. One-third prime, 1/3 pi. Sorry. If you leave that 1.8 out and have an H prime instead, you can solve it for any height.
Yeah.
You don't want to just solve it for 1 point. You want to set up the equation so you can solve it for any height that you can, where the rate of volume is changing.
Right.
So take that 1.8 out and put H prime. And then H prime. So it'll be R prime over 1.15 3.6 H prime. And this is going in your equation for dV dt. Excuse me.
And then times it by H.
That's you talking about this right here? This H?
Yeah.
Yeah, that's the other H. So in there. You got it from there. Okay. And you can simplify this by taking the H's out. Need to erase something. Erase dV dt.
It'll just be H squared.
H cubed. DH cubed. H cubed. I'm sorry, I'm just slow. I'm trying to take Y'all can't see that, can you? Okay. I'm right here. A little bit, little bit, little bit. What that'll do then? That's good. I'm right here in the problem, and I'm trying to get here. So I took the derivative of all this dvdt. So when I got here, can you see it? Can everybody see it? One-third. 1/12. Okay. 1/3.
This should be 3h squared. Derivative.
This it'll be that, and then simplify, and then take the derivative. You see how I got this though?
Yeah.
So you simplify this and take the derivative of that. After you simplify that, 1.15 divided by 3.6 times 1/3.
You wouldn't square the 1.15 over 3.6?
Yeah. Thank you, Doc. Thank you. .6 squared times 1.1/3 equals .030. Cubed. Oh, excuse me. DH dt. Is that cubed? That's cubed. That is cubed.
We have to do dh dt. Yeah.
You mean like 3a squared? And then put that in here. Over pi dv. You solving for dh dt.
Yes, and then you just
How
divide.
far you got this. I want you to take it at a very point. How fast is light rising when it is point at G? How fast is light water rising dh dt? That's what you want. You want dh dt. So that is on the end. Okay. And solve for dH dt. Just plug 1.8 into this equation. You got dV dt, which is 0.5. 0.5 equals 0.034 pi 3 1.8 squared dH dt. And solve for this. Excuse me. Let's solve 1.8 squared times 3
DH.
9.72 times 5 times 0.034. Is that what you got?
Yep, 0.48.
0.48. I could have did something wrong. I could.
Because it was like
I'm looking at back.
0.5 divided by 1.038. Yep.
Oh, this 17. It's not in the back. Solution. You got the solution manual?
No.
No, you don't got it with you.
So it's like you do 0.5 divided by pi times 1.15 times, or divided by 3.6 squared times 1.8 squared.
Right here.
Yep. So you do 0.5 divided by all that.
Yeah, I got 0.48.
That's what you got too? Okay. As long as y'all got the same thing. 0.48. Did I go through that okay though?
Mm-hmm. Yeah, it's just 0.5. Yeah, solve for dH dt.
You want to do another one?
You just take all that and divide it.
Yeah, the main thing is relating these into the equation.
Right.
I can do another one though with the same. I can do this one. You want to go through this one?
Yeah.
Okay. How you doing? Okay. This one says, a tank in the shape of an inverted cone has a height of 4 meters and a radius at the top of 2 meters. So 2 meter radius. Appreciate that. 4 meters height and a radius at the top of 2 meters. R equals 2 meters. Water is flowing in tank at a rate of, so dV dt, volume over time, is 0.314 meters cubed over time per minute. How fast is the level rising when it is 1 meter deep? So you want to know dH dt. Volume of a cone.
That's at 1 meter.
Where?
You
Right here?
say dH dt at 1 meter?
No, you're looking for dH dt. Oh, at one, you get
Is that what he said?
1 meter, at 1 meter deep. Pi r squared h. Okay, let's relate our original equation to our cone and what we're looking for. That's our big cone. This is our little cone. Our big cone looks like this. And our little cone is RH. So basically it looks like that. We're going to relate these cones to each other again. So 2/4 equals R/H. We want it in terms of R. So cross multiply. 4R equals 2H. Oh, sorry. 4R equals 1/2 H. We're putting this R into our equation up here. Pi 1/2 H squared H. Simplify. One half squared H cubed. One half squared 0.25 times 1/. What I do next?
You want to the derivative, right?
Yep. Like that. And then, can you erase this? dV/dt. You can do this. So dV/dt equals 1/4 pi h squared dH dt. And then plug in each other from there. You're looking for dH dt. You can plug. They want the. They want to know the rate at 1 meters deep. So you can plug it in here. 1 squared pi 1/4 dH dt equals 0.314 meters cubed a minute. You could times about 4 divided by pi. That 1 doesn't matter. Equals dH dt. And that should be .40 meters a minute. That what you got?
What,
It
point
should-
four?
Yeah,
Point
it
four?
should be .4 meters a minute.
Okay.
He didn't give you, I know last time he gave you a sample quiz. He didn't do that this time?
Nope.
Or solution. See what we got there. We might need to go back and do that. Is that 17? Number 17? That's not the same one.
No, he said there was going to be one, like the boats. You know how they were, one's going one way and the other one's, and you find out where they meet. No, he said something about that. I can find out what number that is.
Okay.
Which one are you trying to do?
Find that boat.
Oh, we're still on 4-4,
No,
aren't
go ahead. I'm gonna look
That
for
was
this,
on 4-8.
It's 4-7.
we? 4-7.
So 4-5 and 4-6 aren't gonna be on there, right?
Yeah, they say just 4-4, 4-7, 4-8. You said C 4-4 example 2. Good, take me right back in.
Number 17.
I thought he had the solution, but I don't see it. Because we already did it, but I wanted to check the answer. What section was that boat one you talking about?
Now 4-7. I said see lecture notes. It was 4-7, number,
Homework 4-7?
yep, number 13, you want to hit?
Yes. This for the length of the Can you raise this?
I thought that one was hard. You guys
Tom?
think that was hard? Did anybody do the homework?
Yeah, I thought it was difficult.
4-7.
Number 13.
Number 13. 4-7, number 13 reads, Ship A is traveling due east at 18 kilometers an hour. Ship A is traveling due, this is my ship. East. 18 kilometers an hour. Kilometers an hour. As it passes a point 40 kilometers due south. As As it passes a point 40 kilometers due south of ship B, which is traveling due south at 16 kilometers an hour. Ship B is traveling. Ship B is traveling south
At 16?
16 kilometers an hour.
It's kind of confusing.
So we're saying it passes a point 40 kilometers south, 40 kilometers south. So this distance, 40 kilometers. And then how much later are the ships nearest each other? Okay, one ship's going down, the other one's going, got a triangle. One's going this way, one's going this way.
It's hard to grasp without looking at that picture that he made.
You don't see it?
You know what I mean? Like, I didn't see him draw it the first time.
What was the? Could you just read through the equation again?
Okay.
I don't have the book with me.
Okay. Ship A is traveling due east at 18 kilometers an hour.
Okay.
As it passes a point 40 kilometers due south of ship B.
Okay. Yeah,
Which-
that's what I thought. So shouldn't A be south of B then?
Yeah.
Because if you do that, then they're never going to cross. A should.
Okay. You're right. So B. So A is south. This one's going.
Yeah, A should be straight under B, shouldn't it? Or
I don't think so. Then,
it says it passes the point directly south of it. 40 kilometers.
okay. So that's 40 kilometers. This is B. A is traveling this way. B is traveling this way. Is that right? 40 kilometers. Put this on. Okay, I'm gonna go through his notes too. Is this online?
Yep. Under 4-7 homework solution.
4-7 homework solution. So this will be up there. Number 13.
Maybe he's passed.
Okay. Let x be the distance in kilometers from the origin. So I'm going to put the origin right here. Let the x be the distance in kilometers from origin to ship A, or right here for this graph. For this one. Ship at the time, let y be the distance in kilometers from the origin 0 to ship B at a time in hours. Let D, so D equals rate times time. Distance equals rate times time. Rate equals distance over time. Let D be the distance in kilometers from ship A to ship B at a time T in hour. Of course, find the time at which D is at a minimum value. So you got a right triangle. We made a right triangle with what we're looking at. That's Pythagorean Theorem. A squared plus Y squared equals, A squared plus B squared plus B squared equals C squared. So you're going to relate, you're going to give them all of them, you're going to give all the distance, they're going to be like functions of time. instead of just distances. So 40 minus 16t. This one's 40 kilometers an hour. T squared.
So you said D up is
D equals y squared.
for some reason X is 40 minus 16. I'm not sure why that is. So it's 40 minus 16 t squared plus 18 t squared.
Because B is traveling at 16 kilometers an hour or something like that. So an hour's time would be 40 minus 16.
Oh, okay, well, that makes sense.
This one's going 18. And then all of them going to be in distance, so therefore x. This one's going to be x. 18 times time. 18 t. This one's 16 t. Is that what I got? 40 minus 16 t. This one's 40 minus 16 t because they were 40 kilometers apart in the y direction
Right.
from the beginning. So distance times time is the way he going this way. So you got to go 40 minus that 16t.
Gotcha. And then set that up as your D, right?
Yeah, and then just
D equals square root of
plug that in here. Let me write that again.
X squared plus y squared.
And put d squared equals x squared plus y squared, or d equals x squared plus y squared. Yeah, and just plug and chug from there. How does it take the derivative? Let's find out. Because you're looking for
So be the square
time.
root of
Look for
1600
time.
minus 1280t plus 580t squared. Once you do it out.
So for right now, just plug these numbers in here.
Right.
I'm gonna have to erase some. Like that. Okay, I'm gonna erase the picture and foil this. $40 times 40. Well, he got the foil right there. I'm not. I'm not gonna foil that and all that. Do the math on that. I'm just gonna take what he got, and he comes out with a function of plus 1600. And he had all that under there, but he just took it to the 1/2 instead. To the 1/2. Minus 1280. And then just take the derivative of this
1280?
Hmm?
Where's the 1280?
Okay.
You come out with 1280 whenever you do the full, like when
Yeah, the 4, you got a 4 of this?
40 minus 16t
Okay.
times 40 minus 16t.
And then 18 squared. 18 squared. I mean, that's
Well, 18 squared is 324.
324 t squared.
But
This is
Okay, I got you.
you got it?
Yeah, I got it.
Okay.
once you do it out, I guess.
I just didn't know if you could just square both things inside, but you can't do that.
Yeah, looks like everybody.
Yeah.
All right, 40.
And then take the derivative of this, which is 1/2 times this, which was what's the can you help me out with that?
Product.
The chain rule.
Chain rule. I don't know about heart, man.
Du times u.
Definitely don't.
Du equals u to the n minus 1, n to the n minus 1 times u prime. I think that's it. Is that the chain rule?
Gotta find out.
Du equals u to. Let me see. N minus 1. That's right. I think.
Nu to n minus 1, and then in parentheses du over dx.
Yeah, du prime, du dx.
Yeah, that's it.
Okay, so we're gonna take the derivatives, apply the chain rule, and that'll be 1/2 times all of this. $1,600 to the negative 1/2 times, let me erase this, times this prime, this derivative of all of this,
Oh, okay.
which is 580 times 2 t minus 1280. That's it.
Gotcha.
What's that negative 1/2? Is that like?
That's n minus 1 right here for the chain rule.
And that's on the du dt? Or
Um,
still?
right here?
Yeah, it's on that one, right?
No, it's on this one down here.
Okay.
It goes down here.
Yeah.
So it's 5. Okay, he does this. He gets the derivative. He simplifies. That's the derivative. This is the derivative. He simplifies this into 580t. Yeah, because this 580t comes from over here. 580 minus 1280. Can you read that? All this comes out to be 580 t squared minus 1280 t plus 1600. And he just sets both equal to 0. these twos cancel out. This is f prime of x. And he says both the top and the bottom equal to 0, 580 t minus 1280. Minus 1280. Hold on. 580 times 2.
Why are you just doing it on the right side? Like f prime of x?
Right here.
Yeah.
This is the whole thing. This comes to the bottom. Let me show you again.
Oh, because it's negative 1/2, you can put it on the bottom, right?
Yeah, 1/2 can go on the bottom.
Mm-hmm.
All this is to the negative 1/2, so all that can go on the bottom. That's 1600 to the 1/2 on the bottom. And then you left with this 580 2t minus 1280. I think something's wrong with that 1280 though. Those twos cancel out. Oh, the two goes, it cancels this out too. 1280 divided by 2 is 640. So on the top, you left with 580 t minus 640 over this. Over this.
So how'd you get 640?
You see where these the two canceled out right here?
Yeah.
It cancels out right here also.
Gotcha.
Like this, if it was like this, something like this, t minus 1280.
Oh,
It'll go in the boat, it'll go
Yeah.
1 and 1. You need me to make it clear? Let me write
You
over.
just divided the two, canceled both of them.
Yeah, cancel the,
That
I'll write it again if you need me to though.
No.
But, yeah, this one, don't worry about that one. You got, this minus this. That 2 cancel out here and cancel out here. It's just like if you were multiplying it 2 like this, x plus 1. You go 2x plus 2.
Oh, because you're subtracting up top. That's why it could cancel out by.
And then he just takes this, set it equal to 0. He takes the numerator, sets it equal to 0, and comes out with 32 over 29 hours.
Yeah, so that 2, it doesn't technically cancel it out. I mean, you could look at it as 1/2 times 582t minus 120.
Yeah.
You know what I mean? Like you
Yeah.
just times those together.
Like this, 1/2 times 580 t.
Well, it would be 5. What would be 2 times 580 would be 1160. So you could just do
Yeah.
1160t minus 640
Or 1280.
or 1280. Yeah, and then you get your 640 and your
Mhm.
580. So same thing.
That 2 cancels out there. That's it. Can you see it like that?
Yeah.
You want to do another one like that with different numbers or something? Different numbers?
Well, when you get it down to that, what do you do from there?
Right here?
Yeah.
He said he said he got the derivative, set the top and bottom equal to 0, and solve for t.
So
Oh,
580
okay.
minus 640 equals 0, and then
Yeah, you'll get 2 numbers then. And, right.
For the bottom, it doesn't even look like he did the bottom one. He doesn't even.
He just does the top one.
Yeah.
So he sets it equal to 0.
You see, what is it? I should scroll that down early. Yes, he just set the top equal to 0. T equals that.
So how does he know that just setting the numerator to 0 is fine? Like, you don't need to check the denominator or anything. Is that because it's constant or something like that? I mean,
So yeah, something weird on the way the question is asked, because it refers to how much later are the ships nearest each other. So in that case, I mean, I don't know how to explain it, but
Yeah.
you gotta pay attention to what it's asking. You know what I mean? How he's
Yeah.
going over in class. I mean,
Well, so what's the, like, you just don't even care about the denominator?
Not that I see.
it seems like what he's done. Once you get to that point, you just
And it'll be more. It's gonna be more a headache too with the denominator in it, because that's a quadratic. So you're gonna get two t's at the bottom also. They should be one of the. We can try it. See what we get.
and one of them might be actually like
the
the
one,
top.
yeah, the one at the top.
Maybe.
You wanna try it?
If you can, yeah, if you don't mind running through it like really fast.
So at the bottom he got 580 t squared minus 1280 t plus 1600. That's t. That's some t. That's some t. 40, 40. They're gonna be positive.
So it'd be like, well,
They're gonna be both minus.
yeah, 580 divided by 2 would be, let's see, 290.
290.
What would that equal?
Yeah. Then you got times it by 40.
Yeah, so that's not gonna work. So let's see, 290.
580. We tried 290. What is it?
Times it by a certain number. There's a common denominator there, like 10 or something like that.
58 too.
290.
Yeah, see, it's just more. We go this way, 58 times 40, 23, 20, and then that's already too much. I would just remember for this problem, just take the top.
yeah, if it asks like,
Yeah.
I swear I remember him saying something about that. That type of question was going to be on our test. So.
I don't remember it being a test question, but it's
Oh.
possible. Any homework,
That
any
was
homework.
There should have been a plus and a minus, right? One was a plus, one was a minus, because you got negative. Well, I don't know. I don't know how you get negative 100 and
Which one?
the center there is a minus. It's minus what?
580 T minus
1,000.
640?
Well, it's minus 1,280 T.
I don't see what you're talking about.
Third line. So at the end, he has in the denominator minus 1,280.
Oh, and I had some different. No, I had for that quadratic when I had two negatives. That's gonna be a positive, and then they're gonna add up to be a negative.
Okay.
That's why I had it like that. Because when you're gonna multiply them at the end and add them in the middle,
Yeah.
so they're gonna be negative. Curve sketching?
Yeah, let's do it, man. Whatever. Yeah, on everything.
Which section did curve sketching come out of?
Yeah, it was 4.
I think the last one 4-7. I think
Oh,
Using derivatives and curve sketching.
4, 4, 4,
4-6, right?
4, 4, 4, 7, and 4, 8. And graphing polynomial is what you said the test was going to be on. So curve sketching is,
We don't need to go we don't need to go over any of the curve sketching.
Yeah, that's right.
Sketching in 4-6 because that's not going to be on the test.
yeah,
Yeah.
graphing polynomials is,
So we could start out with 4-4 and then 4-5 maybe. Or
Graphing polynomials is that in 4.8.
4-8.
oh, really?
Well, that's not in 4.8, but I mean, you said graphing polynomials is going to be on there. That was like the. Which one was that?
He wrote down that there's going to be one problem from section 4-4, one problem from section 4-5, one from 4-7, and then 2 from 4-8.
Yeah, they said there's only 5.
I didn't see where he said about 4, 5.
He wrote that on the morning, like, first thing.
So 4-5 is on it?
4-5 is, yes. But 4-6 isn't, which was kind of the...
I don't see any problems for 4-8. Do you have any? This one right here, you talking about polynomial curve sketching? Can you see that?
Yeah, I mean, I think, yeah, because
Yeah, that's what
graphing polynomials is what he wrote.
It's a 4.5.
Yeah.
So,
Yeah, because that's like the chart with the increasing, the relative minimum, and all that.
Okay.
Is 4-2 not going to be on it at all, I guess?
I don't think so. 3x 5 minus 5x cubed. I'm gonna graph this one. Sketch the graph y equals 3x to the 5th minus 5x cubed. Using calculus, determine those values of x for which the function is increasing and those values of x for which the function is decreasing, and find any maximum and minimum points on the graph. So first, we'll take the matter of fact, I should go down his I'm gonna go down his list. So first domain, that's but the domain is all real numbers. Real numbers. XY intercept. 1, 2. XY intercepts. You said y equals 0 for the x intercepts. And said 0. Let's solve this one first.
Where'd you get that from?
X and Y intercepts the
With the x cubed, where'd you get that?
oh I forget what you call it, but you see how the least common denominator, x is x cubed?
Mm-hmm.
So I took x cubed out of both of those.
Okay. I got you.
And then that's what's left over.
I didn't see that.
That's cool. So x equals 0. And 3x squared minus 5 equals 0. 3x squared equals 5. 3x squared equals 5 over 3. X equals cubed 5 over 3. I think that's right. Oh, yeah, that's right. Okay. So these are your x and y intercepts. X-intercept, square root of 5 over 3 and 0. And this is going to be a plus or minus. So that's 2 points. Plus or minus. How do you write that? Plus or minus to
On the outside.
On the outside. 5 over 3.
I can't really tell.
Huh?
In the center section there, you have x equals 0, and then you have, what is that, 3x squared minus 5 equals 0?
Yeah, this is for the x. You said
x to the third equals 0. Yeah, I got.
And then
okay.
said that.
But then you have
And then you just solve for x.
3x squared minus 5 equals 0.
Yeah, you said both of these equal to 0.
And then you have below that, it's hard for me to see, so
Okay.
I'm just kind of going through here, trying to make sure I see it all.
You can write again.
3x squared equals 5.
Right here.
And then you
Yeah.
divide
Yeah, 3x squared equals 5. Divide each side by 3.
Okay, and then you take the square root of 5 over 3.
X squared equals 5 over 3.
Okay, I see now.
Okay. Got that? Everybody got that? So you got x equals 0, 2. And y equals x-intercept, y-intercept. Y equals 0. That's from right here. X-intercept, y-intercept. Determine the behavior for f for large absolute values of x. So you want to know what it's doing, increasing. You're going to take the limit x to negative infinity and limit x to positive infinity. So I'm going to write my intercepts down here. Work out. I'm going to erase my this side for now. You got this side?
Yeah.
Okay. X, everybody got x and y intercepts? Domain, okay. 3x to the 5th. We take the limit of leading coefficients. Plug negative infinity in here. You come out, it's odd exponent, so it's going to be negative times a positive is a negative. That's negative. Plug a positive infinity into, that's positive, positive. Positive, so that means that when you're coming from positive infinity x, it's coming from positive infinity y, like that. And when you're coming from negative infinity x, it's coming from down here. That's all.
I want to go the other way.
Huh? Which one?
I want to go from negative infinity to positive.
Negative, if you're coming from negative infinity x, it's coming from, yeah, you're right. It's negative. I'm sorry. If you're coming from positive infinity x, which is this way, it's going to be positive.
Going to the top.
Yeah. Sorry about that. Appreciate it. Determine the intervals where f is increasing, where f is decreasing, and find any relative extreme. So this is where we take the derivative of the function. Derivative of the function is 15x to the fourth minus 15x squared. Set it equal to 0.
Wait, where did you get that from?
This is the derivative of the function.
Oh,
15x to the 4th?
Yeah. Appreciate it. And I set the x and y equal to 0. The y equal to 0. Basically, you find your root, so your derivative, set the y equal to 0. I'm going to take 15x squared out. X squared minus 1. 15x squared equals 0. X squared minus 1 equals 0. X equals 0. X equals plus or minus 1.
Square root of 1?
Hmm?
Square root of 1?
Yeah, that's the answer, though. You're right. Square x equals 1. X equals square root of 1. X equals plus or minus 1.
That's the intervals.
Yeah, those are your critical points.
Okay.
Draw a number line. And you have your points as critical points. So it goes 0, 1, negative 1. I'm gonna erase this limit stuff. That's fine.
Mm-hmm.
You have your number line, and you get your test values. So let's pick negative 2, negative 1/2, 1/2, and 2. So the way I'm gonna do it, I'm just gonna plug the I got f prime. I'm gonna plug negative 2 into f of prime. I'm putting my calculator. 15x to the 4th minus 15x squared. It's not squared. Squared. Graph that. Table equals 180. It equals 180, but you're just worried about positive and negative. So f prime of negative 1/2 equals plug that in. Value negative 0.5 equals a negative. Equals 180. 2.8125. Oh, 1/2. So once you get all these positives in your intervals, you know where it's positive, it's increasing. So on this interval, it's increasing. On this interval, it's decreasing. On this interval, it's decreasing too. This, is that right?
Yeah.
That's right.
Yeah, positive, negative, negative, positive.
So that means right here you have a maximum, and right here you have a minimum. To find the minimum, maximum points, you see the minimum, you see the maximum is at -1. You plug that into your original equation to get the maximum, right there. Y equals 3, -1, 5 minus 5, -1 cubed. What you get for that?
You looking for the maximum?
Yeah. And then the minimum is y equals 3, 1, 5 minus 5, 1 cubed.
Maximum would be y equals 2. X equals -1.
Oh, it's -1, 2. You said 2, right?
Yep.
And this one would be 1 and something.
-2.
-2.
Yep, 1, -2.
So you got minimums, maximum. Okay, after you do that, you got increasing, decreasing. You want to know the concavity, concave up or concave down.
So you take the derivative of the derivative, right?
Just double
The second
prime. Yeah.
And you plug in your critical points.
Yeah. Start a number line and do your credit. What am I dy? I don't got dy dx. So I'm gonna erase all this. It's cool. Same thing when you was finding the increase and decreasing. You want to do with that's dy. Let's do it like that. That's y prime. This will be y double prime equals 15 times 4. 60x cubed minus 30x. Set it equal to 0. 30x. I'm going to take 30x out. And I'm left with 2x squared minus 1. 30x squared equals 0. 2x squared minus 1 equals 0.
Equals plus or minus 1/2.
Number line. What were the y what's the x and y intercept?
The maximum?
No, just the intercept when we did
Plus or minus square root of 5/3.
Okay.
That's the x. 0.
And 0.
Y equals 0, yeah.
Okay. 0, 0. Okay. Number line for concavity is plus or minus square root of 1/2, which is around 0.7. So about right here, let's say that's 1. That's plus square root of 1/2. And say this is 1, this would be minus square root of 1/2. You can use -1 test for test 0 and 1.
You plug back into your original.
Go back. No, these you plug into the double prime.
Okay.
You see what we did the first, the increasing, decreasing, and I'll use 0 as a critical point. You don't have to. You just gonna use -1 and 1.
Yeah.
You see how I got that double line like this when we did that last number line?
Yeah.
Remember that? It's because 0 was in there. You don't take 0 out.
We didn't use 0, did we?
We didn't?
Negative 1/2 and plus.
Yeah. For a critical point, we didn't use 0.
We just used -1 and 1.
Cause he did. Yeah, but we see how we use split an interval up with 0. Just you don't have to just take 0 out.
You don't have to put 0. Yeah.
Because it adds another interval in there. It's the same interval. That's why both of them are going like this.
So
take 0 out. And then so this is your interval. F double prime of -1 Everybody know how to use the value button, value option for the function?
No,
Huh?
I don't think I did.
The value, can you see the calculator? From here?
Now I can.
Okay. Plugged, so we're using double prime?
Blur.
Blur? Okay. 60 x cubed minus 30 x. Graph that. And then second trace a value. And you just put in your x value. We're using negative 1.
Yeah, that's right.
Okay.
And it gives you negative 30. So just be careful when you got to switch back to the when you got to switch back to your original equation. Be careful with that.
So where'd you go to do that? I'm sorry.
Start with y equals.
Okay.
Type in the function or your equation.
All right, graph.
Graph it.
And then what?
Second trace. And value is the first option. And then just type in the value you want to find, the x value. In this case, it's negative 1. And then it gives you negative 30.
Oh, yeah. I got you.
Why is mine doing all weird?
Cool.
So you can just list them down like this: f of 1, f of negative 1, f of 1. Just plug them in. F of 0 is not on it. Yeah, f of 0.
Yeah,
So-
when you're using whole values, you can even hit second function table, which is above the graph,
Yeah.
and go that way too.
You see that?
Look at them all.
But I don't think the table, they won't do decimals with it.
No, yeah,
can-
you'll have to do the value if
Okay.
you want to do
Decimals.
decimal.
I'm getting like, why am I getting an angle? I mean like theta and r.
Let me see. You might have radians. You might be in
I put it
radians.
in degrees.
Oh, it's in degrees.
Yeah, you have to make sure your table's set first.
30, 60.
It's like it won't even let me graph two graphs on there. I've been having trouble with that.
Yeah, it does give you radians. I bet it's in like radians somewhere.
I mean, I just switched.
Yeah,
it,
I know.
It's like,
Yeah, I see it right there.
it's in degrees. So
Yeah.
it should be in radians?
No, it should be in degrees, but
Yeah.
it seems like you're giving it back to you in radians.
Yeah. I have no idea.
Is there options up here somewhere? In the graph and everything?
I don't know. I'll mess with it.
Okay.
Plot was selected, like the top.
Oh, Google's good
Plot
for
one was highlighted?
the TIs. Google?
And
Mm-hmm.
Yeah.
graph.
Yeah.
Okay.
Because I had to Google the simultaneous equations,
Okay.
and it laid it out pretty good.
You're welcome.
So, you know that this concavity is down. Down. F double prime is 0. Did you finish that?
Oh, yeah.
What was the answer for that?
For 0?
Yeah.
Oh, I don't know, man.
For 0.
I didn't. I'll figure it out.
Should
Though.
be 0.
Yeah. And then F of 1,
One's 30.
30. Positive 30?
Yep.
So that's going up. And it's doing something in between. But I did 0 on this one. I don't know why. So I need that in this one. I need another. Let me start over. I need that 0 interval in there.
It's kind of an odd shaped graph, though. You know.
We'll do it like this.
Like, 'cause it does,
like a
like-
wave.
Yeah.
or something.
Right.
So that's why you got it. Yes. going back and put 0 in? Or are you changing?
Yeah, I'll put 0.
1/2.
I put that 0
that's
interval.
the,
I put it in the
X and Y intercept, right?
Yeah. No, this is the same thing. I'm doing the same thing.
Okay.
The double prime concavity.
Gotcha.
I fixed it.
You got it?
Yeah.
What'd you do?
I went to like the graph format and it was on something.
Oh, okay. It was something weird.
It was like go to format graph.
Uh-huh.
I had to turn it and say no.
Oh, okay. Oh, polar GC?
Yeah.
Okay.
Yeah. I had to put it on rec.
Yeah. It's a conversion or something between them. So, concave down, concave up, concave down, concave up. And everywhere in the middle is a point of inflection. So to figure out where these points of inflection are, put these x values back into your original equation. So after you see what they're doing, concave up, concave down, find your points of inflection at 0.7, 0, and positive 0.7 with the original equation. So you would do this, f negative 0.7 or negative 1/2 square root of 1/2 equals, and the other value, that's your inflection point, whatever this is. So 3x to the 5th minus 5x cubed I get 1.24. Yep. And you do the same thing for both, all three. And then you want to draw it after that. Can I erase this? What can I erase? This side? This side? Y equals 0. That was the x-intercept, right? So we know it's coming from this way, right? And like this. We have some critical points. Well, we got x-intercepts and y-intercepts first, so you know across right there. Square root of 5/3 is around 1.3. So positive and that's square root of 5/3. Negative square root of 5/3. You know it crosses at the y, 0, 0. What's you got the minimum maximum points written down?
-2 or 1 over or -1, 2,
Max.
and
That's a max.
-1.
and -1, 2 would be max.
No,
It was
This is
the other
max.
way.
1, -2, -1, 2.
Like that.
No, max. Your maximum is -1, 2. Then
Max.
your minimum is 1, -2.
Like that.
Yep.
Yeah.
Like that. 1, -2. This is 1.3. 1, -2. That's 1, 2. And -1 and 2. That's 1.3, 1, 1, 2. That is this is the minimum. This is the maximum. And it crosses the x-axis at 5/3. So we're looking like this. Maximum, crossing the y. Minimum, crossing back right here. And up like that. But
That don't seem right. Square root of 5/3?
Is 1.3.
Yeah.
And,
So actually, that minimum
oh.
maximum point should be out.
Huh?
Further.
The minimum maximum point?
Yeah, shouldn't it be out further?
But what, so you're saying that's not these right points?
No, I guess that is right. No, it should be about right there.
Yeah, 503 is like 1.3.
Yeah,
So
it should be. You're right.
okay.
I was thinking the other way around. I was thinking X was 2.
And when you do that, try to get the concavity, concave down. This is concave up. This is concave down. That's a point of inflection.
So it passes. So it comes up and it passes through negative square root of 5/3.
Yep.
Is that right?
Yeah.
Okay.
That's an x-intercept.
And then it concaves down.
It's and that's concave down. Let me do this again.
Yeah, it's kind of hard to do. It's so small.
Yeah. So you got -5/3. 5/3. It crosses the y. You got 1
should be
negative
right
2.
there.
1 negative, that right here. And this one is -1. Okay. You see that? And make sure you get the concave down. You know what's coming from this way, concave down, concave down,
And then it
concave
goes
up,
down.
concave down, point of inflection,
And then up.
concave up, yeah. But it goes through this point.
Yeah.
That'll wrap up today's session. Hope I explained everything pretty good. See you next week.
Okay. Sounds good.